Alright guys, welcome to another exciting section of geometry here in our circles chapter. We will be talking about different lengths of segments that result from different types of segments intersecting in circles. And there's really three little possible cases. They each have their own formula, and you just need to be aware of which situation your problem's dealing with. If you see on the diagram here, the first possible case is if you have two chords that intersect inside the circle. So again, remember, chords are just segments whose endpoints are on the circle. So you see the picture there again, two chords, they have an intersection point inside the circle. The second possible case are two secants, and secants are actually lines that intersect the circle in 2 points, right? So we can see the one segment intersects the circle twice, and then the second segment. Now the key here is that these secants need to have the same endpoint. So you see they have an endpoint there. And then the final option, you have one secant again. So again, a secant is going to intersect the circle twice. And then you have a tangent, which we saw earlier in the section. The chapter intersects just it only intersects the circle at one point. Remember, that's the one that forms the right angle with the radius and all that stuff. But if you have one secant and one tangent and they intersect and they share an endpoint, again, there's certain conditions. And these two actually kind of go together. We'll see when we talk the formulas to show the formulas. When we talk about the formulas. So they're really related, but again, they are kind of separate. Visually at least. So let's jump into it and see how to solve these problems. Alright, so case one, let's say we have two chords. So you see DC is a chord and AB is a chord, right? And they intersect inside the circle. And the rule, or the way to find segment lengths, generally what will happen is they'll give you some lengths and have you find another one. And we'll do an example later in the lesson. But the formula here, the way this thing works, is that the length from D to E times the length of EC. Okay, so I'm kind of doing a piece and then the other piece of one chord equals a piece times the other piece of the other chord. Okay, so one piece times the other piece equals, go to the other chord, one of its pieces times the other piece. Okay, and they'll give you 3 out of the 4, and you should be able to, we'll do some algebra and kind of solve for the 4th missing piece. So again, we'll do example in a second. Okay, but that's the rule for that one. The next rule, or the next case I should say, if you have two, I'm sorry, this should say secants, and I missed that typo there. We have two secants. I used these notes before years ago and never caught that. Or if I did, I forgot to change it. But let's say we have two secants. Okay, so AE is a secant. BE is a secant. They have the same endpoint, point E. Okay, the way this one works, and this one's a little tricky because there's a certain way you need to do it. Let me write the rule and then we're going to dissect it a little bit. It is that the length DE times AE, okay, so DE times AE must equal CE times BE. Okay, so that one might be a little different than you might think. It's not piece times piece. Okay, it is actually the outside piece times the entire segment. Okay, so notice, right? DE is the outside segment of the circle. AE is the whole length of the whole secant. Okay, and then same thing on the other side. CE is the outside piece, and BE again is, notice, the whole or the entire segment. Okay, so it's not like outside piece times inside piece. Okay, it's outside piece times entire piece, and it has to be that way. It cannot be. You can't do AD times AE. It's not. It can't be the inside piece at all. It's just outside times entire equals other outside times entire. Okay, and again, we'll do an example in just a second. Let me just get the third and final case. Okay, and this one is the one I was saying was kind of similar to the previous example. So again, this one has one tangent, right? CD is a tangent right there. And AC is a secant. Okay, and we can kind of use the same thoughts here where it's outside piece times entire piece. Okay, so if you think of it along those lines, outside piece, BC, times the entire piece, which is AC. Now on the other one, the outside segment is CD, and the entire segment is also CD. Okay, so when you have something multiplied by itself, it's equivalent to thinking of that term squared. Okay, but it's still following the same thing, right? It's like outside, outer times entire. Okay, and over here, same thing, right? CD is kind of like the outer, and then CD, since it's a tangent, right, is the entire as well. Okay, so let's do a couple examples, put some numbers in, and kind of get this worked out. But those are the three cases. Every problem you'll see will use one of those three, and basically you'll be given all but one of the lengths, and you'll solve a little algebraic equation. Alright, so example 1, let's find the value of x. Okay, so this one again I'm looking at, I see that there's an outside piece and an inside piece. Okay, so this is not the one with the two chords, this is actually two secants. And I'm going to follow the rule that said the outer length. So let's do this secant first, right? So that's secant. The outer length is 11. Now the entire, remember it's outer times entire. Okay, the entire segment is 21. Okay, and that's going to be equal to, same thing on the other one, right? Outer is 12. Now what's the length of the entire segment? 12 plus x. Okay, so again, I knew this was outer times entire because it had an outside piece and an inside piece. So now we just do a little calculations here. 11 times 21 is 231. Okay, we can distribute the 12 here. 12 times 12, 144 plus 12x. And now we can just go about solving an equation. We can subtract the 144 from both sides. So we will get 87 equals 12x. And when we divide by 12, we end up with our answer that x would need to equal 7.25. Okay, and if you just want to kind of check it, you can always check these and just make sure that it follows the rule, make sure we didn't make any mistakes. If we check using the formula, so outside times entire piece needs to equal outside times the entire piece. If x were 7.25, that entire piece would be 12 plus that, which would be 19.25. And we can just kind of check it out. The 12 times 19.25 does equal the 231 that we had over here. Okay, so we feel like we got that right. When you have lengths outside, outside the circle, that's your clue that it's going to be outside piece times entire piece. Okay. All right, another example. Can we find the radius of the circle? All right, so this one appears to be using a tangent, right? That segment that is 24 units long is a tangent, and the other one is a secant, right? So the secant is the one, of course, that intersects the circle twice, right? So that's a secant, and I know this picture is not to scale. The 24 length and the 12 length look the same, but anyway, let's just go by the numbers. So this one's a little tricky. It wants us to find the radius. But what we need to use is that we're going to use similar to the last one where it's like the outer piece times the entire segment equals the outer piece times the entire segment. But the one with the blue one here, the outer piece and the entire segment are the same, right? So this is the one that's going to have the 24s getting squared. But first off, let's just say that this inner piece here is x, okay? Let's say that it's actually the diameter, right, of the circle. Let's just call that x because that's the inside piece, and then what we'll use is the fact that the radius will be half of whatever x ends up being. Okay, you see what I'm saying? Like, so just to see it again, the outer piece is 12, and I'm going to call the inner piece there to there, I'm going to call x. Okay, so let's set this up. So it's going to be the outside piece 12, okay? The entire segment is 12 plus whatever x is. Okay, so outer, just to label this one, just a little bit more detailed here. Outer times entire, right? And then for the other side of the equation, the outer is 12. I'm sorry, 24. But the entire piece is also 24. So that's why it's 24 times 24, or it's 24 squared. Okay, so if we go through and do our algebra here, distribute the 12, we are going to get 144 plus 12x. 24 squared, you can check, is 576. Okay, we'll go ahead and subtract the 144 from both sides. So we get 12x equals 432. Okay, dividing both sides by 12, we will get x equals 36. Okay, x again is that entire inside piece, right, which is the diameter of the circle. So that means that the radius, which this question actually wants, is half of that, which would end up being 18 units. Okay, so a little trickier. So just kind of set it up, label the picture, the diagrams. That's a good tip too on SAT and stuff like that. On any problems actually, go ahead and label the picture. Set it up. Use the sketch. I'm very visual myself, and I need to write things down and draw a little label where X is and set things up. Okay, let's set up one last one since we didn't see the first case, and I just want to make sure we see all cases here. Previous examples, so hopefully that. The one other case, which we did not see, I'm just going to do a quick bonus example here, and this is not going to be to scale or anything, but just to see it in action, this is the simplest case, but we didn't do one. Let's just say, for example, we had 5, 8, x, and 12 or something, okay? So this was the one where it was two chords which intersect inside the circle. This is the one where you do piece times piece equals piece times piece. Okay, we're not doing the whole segment at all. So this one would just end up looking like 8 times 5 equals 12 times x. Okay, I'm not doing entire pieces at all, right? That's because these are chords that intersect inside the circle. This is not a secant or a tangent or anything. Okay, so 40 equals 12x. So when we divide 40 by 12, we will get 3.3 repeating, or 3 1/3. Okay, so I just want to show all cases again, and you just got to make a quick decision. Is it piece times piece, or equals piece times piece, or there'll be a little assignment to follow, and that is that.